If you recall, we already learned the derivative of the sine is cosine and the derivative of the cosine is negative sine. Now we're going to learn the other four basic trig function derivatives. So the derivative of the tangent is secant squared. The derivative of the cotangent is negative cosecant squared. Derivative secant is secant tangent. Derivative cosecant is negative cosecant cotangent. You are going to make a note card on this, but look at the way it's set up. If you know these three, the other cofunction derivatives, notice, are all negatives. So all of these are negatives. And then your answer is just the cofunction. So for the derivative of the tangent, instead of being secant squared, is negative. And the cofunction of secant squared is cosecant squared. Here, instead of secant tangent, it's negative cosecant cotangent. So really, if you know the left side, the right side should be pretty easy to create. So let's just do a couple problems using this. So when I look at the first one, 3a, you have trig functions, but notice you have a quotient, so we have to use the quotient rule because I have x's on top and bottom. So step one is I'm going to apply the quotient rule. So the derivative of the top is cosine of x times the bottom minus the derivative of the bottom. So the derivative of 1 is 0, and then the derivative of this cosine is going to give me negative sine times the top, all over denominator squared. Okay, let's simplify a couple things. I'm going to start multiplying at the top. I've got cosine plus cosine squared x. Notice this becomes plus sine squared x. 1 plus cosine of x squared. Okay, now let's practice simplifying a little bit. Especially if it's a multiple choice, you do need to simplify. Notice that there is an identity here. If you remember, cosine squared plus sine squared is really 1. So I can substitute 1 here. And then notice what happens. Notice you have 1 plus cosine of x on the top and the bottom. So one of those will cancel with the factor. So this is actually your final simplified answer. Okay, let's go down here. So this one is just understanding, do you know what the derivative of the cotangent is? It's negative cosecant squared, and we just have a number in front, and remember, we just keep that number. So that would just be negative 2 cosecant squared. Now, sometimes with the trig functions, it may be easier to simplify it first before you actually start applying the rule. So if you wanted, you can use the product rule here, which is fine. But one thing I'll notice is if I clean this up, so I know secant is 1 over cosine, and then I know cotangent is cosine over sine. So really, this is 1 over sine, which is the same as cosecant. So if you do this first, so really it's just asking me for the derivative of cosecant, and the derivative of cosecant is negative cosecant cotangent. Now, if you did the product rule, you would get the same answer. You would just have to do a little bit of simplifying. Letter D, same thing. I would rewrite this as 2 sine of x first, change it, then it's much easier to take the derivative. So what's the derivative of sine? It's just going to be cosine, and we just leave that constant multiple in the front. Okay, now sometimes we may be asked to take higher order derivatives. So just that means instead of finding the first derivative, which is a slope, we may want to come up with the second derivative, third derivative, etc. Later we'll learn what that means. But real quick notation, instead of f prime, you'll use f double prime. Instead of y prime, you could use y double prime. This is your notation for the first derivative, dy dx. Your second derivative looks like this though. Notice the 2 on the top goes next to the d. So this is saying the second derivative of y with respect to x twice. Make sure that you do not write it like this. This means you're taking dy dx and squaring it. Okay, the other two ways to write the second derivative, again, is notation that you'll see, not as common though. So let's practice taking the second derivative. So you start by taking the first derivative. So the derivative of sine of x is just cosine of x. So that's y prime. And then if I wanted the second derivative, I would just go one more time. So the derivative of the cosine is negative sine, and we just keep that 3 in the front. That's it. Same thing here. Y prime would be 4x plus 6. Y double prime would just be 4, and then the derivative of the 6 becomes 0. Okay. Same idea when we work with position functions. So one of the things that we will learn a little bit more later is if I give you a position function, the first derivative of the position function is the velocity, because the way that we calculate velocity is we do change in distance over change in time. So that's really just the slope of this. And then if you take the second derivative of the position or the first derivative of velocity, that's going to get to your acceleration function. So if you understand that relationship, we can do the same thing. If this is your position function, your velocity would just be your first derivative. So I'm going to bring down the 2, which will make it negative 1.6t. If I want the second derivative, I go again. The derivative of negative 1.6t would just be negative 1.6.